Hello and welcome to the fourth webinar in our series, Jumpstart Your Cloud Journey with Sierra-Cedar and Oracle Analytics Cloud. There will be a question and answer session at the end of our presentation today, so please submit any questions you may have using the questions or chat window located at the bottom of the webinar control panel. Today's presentation topic is Drive Better Insights with Oracle Analytics Cloud. Our presenters are Jason Little, Vice President of our EPM and BI practice, and Sean Suskin, Director of our Analytics practice. Jason, please take it away.
Thank you, Michelle. Welcome, everyone, and thank you for joining our ongoing webinar series today. Today, we wanted to talk a little bit about the webinar series and recap some of the topics we've covered today in previous webinars, as well as kind of set up our session for today. A couple things to keep in mind as we go through the webinar. In our first session, for those of you that were able to attend, we talked a lot about configuring the Oracle Analytics Cloud and the platform as a service option that's available with Oracle Analytics Cloud. So at the beginning of our series, we touched on the configuration options and the components with the Oracle database. We also talked a little bit about the migration considerations when you're moving Essbase applications to Oracle Analytics Cloud. In the second webinar series, we then dove into administrating and designing the Essbase analytics within the cloud. And as you recall, for those of you that attended our second session, that was more based on designing and technical considerations around building Essbase databases in the cloud. Last week, we then addressed more of the reporting side when it comes to creating financial reports, as well as smart view reporting against Essbase in the cloud. So the last couple of webinars have really been focused on the Essbase topic, as well as the first session where we talked a lot about the configuration of the Oracle Analytics Cloud. So with today's session, we're now going to shift gears and really focus on the other components of Oracle Analytics Cloud. So we're excited today to jump into the data visualization functionality within the Oracle Analytics Cloud, as well as what Sean is going to talk a lot about today and provide a demonstration around some of the new features and components of data visualization with machine learning and adaptive intelligence. So with that quick recap, if there are any questions of previous webinars, or if you weren't able to attend a previous webinar, we have made all of the recordings and the session material available online if you wish to go back and see any of our previous sessions. So with that, we'll turn it over to Sean to cover today's agenda and dig into the Oracle Analytics Cloud further. Sean?
Thanks, Jason. Well, good afternoon. I want to thank all of you for joining me today. I have a lot to cover in this hour, and I'm very excited to share this. I saw it for the first time last year at Open World when version 4 of the data visualization product was released. In our agenda, I'm going to begin with kind of a brief overview of just what I mean by data visualization, how data visualization is an integral part of Oracle's suite of analytic products, which is the Oracle Analytics Cloud, or OAC for short. Then I'm just going to share a few words about who I am and why you're even bothering to listen to me, along with a little bit about my company, Sierra-Cedar, and how we can help you with your analytic solutions. We're then going to jump right into some definitions of data science and data visualization to get everybody on the same page. We're going to take a look at an example of a use case for machine learning, and then we're going to have a demo. We're then going to take a look under the hood at the Oracle data visualization product and see just what comes out of the box, the machine learning capabilities that come with this product. I'm going to try not to scare you away as far as getting too technical on the statistics and the machine learning, but I'm going to try and give you an understanding, at least, of just what you get. We're going to then have another demo followed by a summary and some questions. So let's get started. So we'll begin by saying, just what is data visualization? What do you think of when someone says data visualization? I mean, do you understand what they mean? I've dug a lot of definitions up, and it's really a hot buzzword today. And I think, simply put, data visualization helps people understand data using visual analysis. So, if you're used to using spreadsheets, you realize that it's difficult to kind of derive any insights from looking at big tables of spreadsheets. So a visual analysis, shows you patterns, trends, and correlations that you're just not going to see without a visual representation. So in my mind, good visualization makes things much easier. And for me, data visualization means, visually rich, easy to use, data for anyone to use, and from any data source. And that's what you get with the Oracle product. So basically, data visualization is going to help people understand data using visual analysis. And perhaps more importantly, it needs to be agile and self-service oriented. You need to be able to do it yourself. Oracle's data visualization product, of course, is not the only product in this market. And Oracle definitely had some catching up to do with Tableau and Power BI, just to name a few. But I think when version 4 of this product came out last October, Oracle really provided a product with features that none of the others offer. Simple self-service, machine learning, adaptive intelligence, as well as very rich visualization capabilities that are going to show you all of these patterns, trends, and correlations. So really, for people, anyone can use it. Data, any data source, visual, it's rich, easy, and it provides a great visual experience. So that's what we're going to take a closer look at today. Data visualization is really for everyone. Business leaders, I'm sure you understand this, they need to see signals, and they really want to see these signals before their competition. They want to be able to predict faster. They want to be the disruptor in their organization. And the data visualization cloud service, DVCS, is really one of the fastest ways to provide this type of capability. It empowers all of these users to see the signals. So if we look at this example here, data visualizations can come out in all of these different functional groups and many more. And some of these examples, in sales and marketing, it's about seeing demand signals and understanding campaign performance. In R&D, it's about seeing return on investment across portfolios of projects. In human resources, you want to see patterns in turnover and talent progression. In finance, visualizing profit and growth drivers and also cost outliers. And that's just to name a few examples. I'm sure within your organizations, you've got many more. This is just kind of the tip of the iceberg. So the data visualization cloud service is designed really for scaling stories across a company. It provides interactive story navigation, stronger than just a copy and paste static dashboard screens, because this visualization tool provides you with a live interactive screen of your navigated stories. You upload and store your own data easily in the cloud. It's ideal for business leaders who need fast mashups. And by mashups, I mean data blending from different sources. You can share insights where data is scattered in many different places. And this is kind of known as quick sprints, departmental initiatives, for example, bringing together, multiple Excel sheets and combining that with data out of some of your source transactional systems. So really, in just a few quick minutes, you can be seeing all of these signals that we're talking about to drive the better insights that we're looking at on this screen. So, the Oracle BI database license is not required for this tool. It includes a 50 gigabyte capacity to store user data. So really, you can be up, running, and creating the visualizations that you're seeing on this screen, yourselves very easily. It's touch-friendly mobile authoring included. There's raw data to insight in minutes. And what we're really going to focus in on today, one of some of the new most exciting features, at least to me, is how it provides you with machine learning and artificial intelligence capabilities. So just, taking a look at DBCS, it's part of the Oracle Analytics Cloud, OAC, which is really, if you're looking at this screen, a comprehensive platform for analytics. We see data sources and data management on the left, providing pre-built connections to over 50 different data sources, and this is growing all the time. And as you can see on the right, the analysis is open to all kinds of users, not just data scientists. I mean, I don't want to insult any data scientists that are on this webinar today, but really this is opening the door for every user to kind of leverage what data scientists do. I mean, if you're like me, you probably have a lot of questions and ideas that really end up going unanswered or that you can't pursue simply because, you're not a heavy programmer, you don't have a PhD in data science or a PhD in math, and you're kind of stuck. You want to get these things done, but you can't do it yourself, or at least you couldn't in the past. And I think that people like yourselves that are in the trenches, that work and live with this kind of data every day, you're the ones that are best equipped to know which questions to ask. It's not technical people, it's people that are really living and breathing this data that really have questions that they want answers to. And these questions and ideas that you carry kind of unfulfilled could potentially revolutionize things within your own company. You just need the ability to see the signals. And what we're going to show today is how you get there. So just very briefly, when we look at the Oracle data visualization tool itself, the key features, as I said, it can connect to over 40 different data sources. There's very easy data integration on the fly and data mashups. And really the path to seeing the signals is embedded in this Oracle data visualization tool, which is truly self-service. It's an application with a lot of powerful features. Today, we're going to take a much closer look at data flows, adaptive intelligence, and machine learning, and we're going to see how those particular features can really help you uncover some insights that you wanted to have an answer to, but haven't been able to in the past. So let's just take a minute here for me to talk a little bit about myself and my company. I am a wannabe data scientist. I'm first confession here. I've worked with data for my entire career, first as a financial analyst, now as a consultant. I've always been kind of challenged to fulfill. I have lots of ideas, but I'm challenged to fulfill them because, as I said before, I am not a heavy programmer. I can't write code to get algorithms into programs. I don't have a PhD in data science or math. But what I do have is a business sense and knowing that I have to understand what this data is telling me so that I can improve performance within my own company. So, as most of you probably did, I took some statistics courses. You probably took some statistics courses. It's kind of required, in that general education that you have to take when you go to college. And those statistics courses have kind of stuck in the back of my mind. So I've always kind of looked at data, tried to discover the stories buried in the data. And now with this Oracle data visualization tool, I have the ability to fulfill those ideas. And that excites me a lot. And I think once you guys have a chance to look at this, it'll excite you as well. A little bit about Sierra-Cedar. We are Platinum Oracle partner. And really, we are a complete Oracle system integrator. And by that, I mean that we don't just offer services in the EPM space, as you see on the left with PBCS and financial close, or on the right in analytics, but we also provide and implement services to implement cloud ERP. And why that's important is because folks like myself that are in analytics, we have to live and rely on the data that flows into us from those source systems, those transactional systems that we also implement. And what that means is we understand this data, not just from an analytics perspective, but we understand it from a data entry to dashboard perspective. And I think by doing so, our team of consultants, they're not only just technicians or developers, they're really functional experts that understand the business side of the data. And when you're building solutions in today's market, understanding the data, in my opinion, is critical to delivering effective solutions. That's what we do at Sierra-Cedar. So let's spend a few moments here with a little background. I'm going to take you back to ninth grade lab science, and just to show you some principles here that you learned and maybe have buried in the back of your mind. But do you remember maybe this ninth grade lab science class? You know, these same principles that you see on the screen here apply to data science. I mean, I'm not saying that, you know, you have equivalent knowledge of a PhD credentialed data science and after today's webinar. But what I am saying is that some of these principles of science that you learned way back then are applicable to data science. And I'm also going to suggest that you're really using them in your job today. And show you an example. When you talk about a use case, really what you're talking about is answering a question. So we begin really with a question. And because you're most likely subject matter experts in your field, you most likely have an idea ahead of time as to the answer to your question. So here we see that our use case has to do with maintaining a membership base. And the question we want to answer is, you know, can I predict attrition from our membership and determine root causes? I mean, there's our question from our science and data, you know, principles. So you have a hypothesis based on that, and using data, you're going to conduct some experiments, observation, and analysis. You know, my hypothesis basically is the average age of members is increasing. I can see that, and more members are dropping out. So therefore, I think we need to target younger age groups. What I really want to be able to do is prove that. So through my experiments and observation and analysis, probably using a tool like Excel, you know, I do come to a conclusion. And, you know, this process for many of you, like it used to be for myself, is very time consuming, you know, painful, manipulating data, but I'm doing it today. And science really right here is applied to data in order to answer your question. So to some extent, you're performing data science today if you're going through any of these steps, you know, in your analysis of looking at data in your job. So not to get too far ahead of ourselves, you know, just what is a data scientist? It's kind of a very hot term, a hot position, very sought after these days. And here's what the wiki definition of the data scientist is. You know, if we take a look at it, we can see some of the skills required, you know, might seem out of reach, you know, predictive modeling, stats and math. But some of you are probably doing distributed computing. You know, you're sharing information, dashboards, reports. You're doing some storytelling and visualization. So you have some of these skills. If you look at some of the responsibilities, you probably are doing some of that as well. You know, you're portraying information using data visualization techniques. Now, maybe it's just, you know, graphs that you create in Excel, but you're still kind of doing it. You have these responsibilities. So if you think about it, the data scientist is by definition a person employed to analyze and interpret complex digital data as the usage statistics of a website, especially in order to assist in a business in its decision making. So my question is, and I think I already know the answer, you're doing something like that today, and my guess is yes. So like me, you're a wannabe data scientist. And what we really want to do is get you to a tool that can allow you to spend more time in the science and less time in trying to figure out the programming behind it. Now I'm going to just take a jump here and give you a quick word about what we mean by machine learning and artificial intelligence. You know, just to cover the bases, and I want to make sure we're all on the same page. So, let's find out what is machine learning. It's one of the most popular buzz phrases today. It was coined first, believe it or not, in 1959. So it's not new. It's a science of getting computers to learn and act like humans do. It's not science fiction. It's been around for 60 years. We want to improve their learning over time in an autonomous fashion, feeding data and information in the form of observations and real-world interaction. It's really what it's all about. We take it a little further and say that, Arthur Samuel coined the phrase, not too long after AI in 1959. He defined it as, the ability to learn without being explicitly programmed. And this is important because the programming part is the part that always hung me up. The machine learning takes care of a lot of that. These phrases are related. First coined in 1956, artificial intelligence involves machines that perform tasks that are characteristics of human intelligence. So, knowing all of this, we're now ready to kind of explore the machine learning capabilities of data visualization. This is what's kind of under the covers, behind the scenes, embedded within the machine learning capabilities of the data visualization tool. So I'm going to start here with what I'm going to call a use case example, and then I'm going to follow it up with a demo. So let's jump right into our use case example. This is an example of a use case. So, I work in the admissions office. It's a small liberal arts college. My goal is to better understand, what kinds of students end up enrolling at our school. I really want to kind of focus in on, what are their characteristics so that I can, then focus my recruiting on people that are most likely candidates to enroll rather than wasting a lot of time focused in on people that are never going to enroll. So this is a use case that I came up with working with some higher ed folks and noticed that this is the real scenario. I think if you work in the admissions office, they would basically say, yeah, we need to know this. It's really nothing that's really advanced or complex in principle. And really, it's the type of use case that I'm sure many of you face every day, in your job. So all of this, kind of begins with the data. And we're looking at screenshots here that are coming right out of the data visualization tool that you'll see in the demo. And, in the data tab, we kind of select the data that we want to use for our model or create a data set if we don't have the data already there. We're going to create a data flow to display and add to the data set. And basically, we select the data set we want to work with. And that basically is all it is in getting started. So how does this data get in? It can be uploaded from spreadsheets. You can connect to, as I said, 40 different data sources, built right in, and bring that data right into your data visualization tool for you to work with. So what we want to do today with machine learning is we want to train a model using a data flow. For our admissions use case, we're going to use the data flow function that's within data visualization, and we train this model. It simply means that we're taking a data set, probably historical data, and we use the machine learning kind of to teach this model to predict the outcomes based on the data. So in our case, what we want to do is we want to take a look at our admissions data set, and we want to understand the enrollment details so that we can predict who's going to enroll and who's not. And then we are going to understand what some of the drivers are of why these people, decide to enroll and why these people don't. This is, we select the train the model type in our process. And, we want to add the step after we've kind of decided on our data set. In this case, it was the admissions data set. And here is where we come into the first hint of data science. This is where it kind of shows up. We need to select a model type. And as you can see from this screen, on the lower right, there are a lot of different model types and many possible selections. They're built right into the tool. So this is where, you want to maybe do a little bit of homework, but you don't necessarily have to. You don't have to know what these models do on the bottom. And basically what I like to say is, if you remember any of your statistics classes, some of these models might be remotely familiar, but the good news here is you don't have to know what the model is doing behind the scenes, because the math for all these algorithms is built in. All the programming is built in. It displays a full data flow step, and you're ready to go. I'm going to talk a little bit more about this later as far as, what's actually within these algorithms or models. But right now, we just want to be able to click the model type that we want to use. We select the model type and the model script, and all right, so it's going to look like on this screen, like we're going down the slippery slope of whoa, this is way over my head. No, it's not. Once you select the model type, you select the model script, and the model script really is the algorithm that gets applied to your data. Once again, you're not going to see any of the heavy programming or the math behind these algorithms. These are just options out of the box. The scripts are run in the background. They're written in Python. Each of these scripts can be used to predict enrollment, and that's what we want to do. We decide here, because I've done a little bit of background homework. We decide I want to use this logistic regression model for this training model because, we have a number of potential drivers for enrollment decisions. And, if you think about it, there are a lot of possibilities: grade point average, the location, where they went to high school. You can add them all up. So this isn't just kind of a one-to-one relationship. If it's this, it's going to be that. There's a combination of things. So we choose a logistic regression model. However, what I am going to say here, that you don't have to go with just one model or one model script. In fact, it's good practice to use a few models, because we really want to compare results of a few of these different models that basically try and do the same thing but different ways, and we want to pick the one that does the best predicting. At the end of the day, that's what we want to be able to do. We want to be able to predict enrollment decisions, and we want to find which model predicts it the best. So within this script, we require, some entry on some of the parameters. A lot of them come as default, and I usually just go with the default. And, at a minimum, however, I have to select, a target column. So my target column, if you can see the screen here, is enrollment. And the enrollment attribute in my data set is basically a yes or no. I mean, did they enroll or didn't they? I want to be able to predict that. So this is my target column. I click target to select that data set column and that I want to apply the train model to. We're selecting enrollment. I save my data flow. I give it a name, as you can see, enrollment prediction model, and I click OK. Now my model's ready to go. At this point, I'm ready to run this model. We're ready to execute it. I'm gonna run the data flow by clicking on the execute data flow at the top right of the screen. The data flow is going to take a few minutes to run, depending on how much data is in there, and it's going to indicate when it's complete, and then it's done. So the next step here really is, I want to interpret the effectiveness of this model. In other words, I want to understand how it interprets the data, and I want to know, is it good quality? Is it bad quality? Should I try a different model? So here is where I'm gonna, click on machine learning to display scripts and models tab, and in the models tab, I'm gonna select inspect from the actions menu. So in order to interpret the model's effectiveness, once I've clicked on that inspect, you're gonna see three different tabs: general, quality, and related. There's a lot of, information out of the box that allows you to kind of determine and interpret the model's effectiveness. If you look at the general tab, it basically just tells you what you did, what the model is trying to predict, the data set that it was trained on, the name of the script, and the class of the script. Really, we want to home in on the quality tab, because that's the one that tells you how well your model predicted, the results. Did it predict yes when it was yes? Did it predict no when it was no? And how often did it predict incorrectly? this is where you can determine whether this is a good model or not. And if you see on our example here, the model accuracy was 90%. So rule of thumb typically is anything over 80% is a good model as far as predicting the data, predicting the outcome. Here we've got a score of 90% based on our data set, so we can feel pretty good that this model is going to be accurate when we want to predict enrollment. So like I said, for today, I'm defining a good model to mean that it effectively predicts a target column with a very high probability, like, over 80%. Here we got 90, so, we're good to go as far as this training model. The related tab also provides, some additional data sets that further reflect the effectiveness of the model in detail. Kind of shows you some statistics, a heat map, a confusion matrix, and I'll talk a little bit about each of these a little bit later as they're a little more complicated. So once you've kind of satisfied with the effectiveness of the model, you now want to use it to predict outcomes. And this is where we apply the model. We created a training model, and now we want to basically take it and apply it to a data set to find out predict what the values are going to be. So in this case, as we've been going along, we want to know whether or not these applicants are going to enroll or not. We get a data set in. Here's a stack of applicants that we just received, and we want to be able to understand which ones are the ones that are most likely to enroll. Because those are the ones that I want my admissions team following up on, because those are the ones that we should consider to be givens. We don't want to lose them. Then we can work down a little bit lower to the ones that are less likely, and then the ones that aren't likely at all are the ones that we kind of, if we have time, we can go after them. So here we're basically creating a new data flow again, only this time we're going to apply the model to a data set. And the model, of course, is the one that we built in the previous steps. So the apply model step really, allows us to configure, our outputs. We can modify column names. We can choose which columns to include in the data set. And, applying the model, creates a new data set, which is generated by this model with the predicted outcomes included. So, here we add a step at the end called save data, which basically when we run this data flow, it saves our data with the predicted data elements in the new data set. So with this type of insight, the admissions analyst now is able to predict which candidates are most likely to enroll based on these variables. And now with this type of insight, the admissions office can focus on those types of candidates. Hopefully that makes a lot of sense. Now we're going to kind of jump into a demo. So I'm going to begin by opening a project on our, this is the home screen of the Oracle Data Visualization desktop tool. And you can customize this screen to basically, come up and show you, what's important to you. And, this is right now, I have it the way that it comes out of the box. It kind of shows you what's new. It shows you projects that you have worked on, data sets that you worked on, most recently, data flows, etc. And today I am the analyst that works for my sales vice president. And so I have a project that I created, which is a data visualization project, which really is kind of a dashboard providing some typical sales related KPIs that track activities in our pipeline. We can see win probability on our screen, and that's an important KPI that we want to understand. It's indicated at various stages in our pipeline process. Now, if your company operates the way my company does, and a lot of companies do, you're using Salesforce or you're using some tool, maybe even it's Excel, to track your pipeline of opportunities. And win probability typically is entered by the salesperson manually, and it's purely subjective. So these win probabilities are based on what your sales rep thinks, and not necessarily based on, anything that's quantitative. Now, maybe your sales reps are really good. I don't know, but I think it'd be nice to be able to predict win probability based on variables within the opportunity. And we do this by creating a model. So what I'm going to do here is I'm going to go to data up here on the left. I'm going to click on data, and I'm going to select create. And here I'm going to create a data flow. So the data flow begins by saying, I want to add a data. What data are you using here? If I had to create a data set, I could create it here, but I happen to have a historical data set that I've been working with, which is basically my historical pipeline sample demo. And so I select that, and I add it to my data flow. And now I can actually see what this data looks like. I want to add a step here, and my step is going to be, I want to create a model here, and I want to train it. So I've decided, because I'm familiar with linear regression, and I want to train numeric prediction because I'm trying to predict whether we're going to, what our probability is of a win. So I pick numeric prediction, and within numeric prediction, I have 3 possible scripts, and I'm going to select, for this case, linear regression. And really, it's as simple as that. I come down here, and I select the column that I am trying to target, and it shows me all of the data in my data set. I scroll down and I say, I want to be able to predict win probability. There are some additional configuration methods in here, and I typically, experiment with them. They're different regression methods: ordinary least squares, lasso, ridge. You can do simple Google and find out what each of these things mean. You can go with regularization weights, most frequent. There are a lot of configurations here. I typically just go with what came out of the box as default. At this point, I basically, I save the model and I'm ready to execute. And my model is saved. So just taking a look at, some of these models that I built. This is the historical pipeline win prediction model. Basically, it's the one that I just showed you that I saved when I built this out yesterday. Now, I've added an additional step here simply because I know from experience that when you use linear regression, you need to remove noise from inside your data and variables that are very similar. If you remember the data set, if you look below, there are a lot of dates in the data set. And really, these are all the same thing. So if we threw all of these into our model, it would confuse it. So in the select columns step, this is where I have basically, kept all of these dates out except for one, the snapshot date. And that way I can reduce the noise in my model, which is the train numeric prediction using linear prediction. So I basically, at this point, I'm ready to go. I hit execute the data flow. It's going to take up to a couple of minutes to run it. I've given my model a name, and now, when it's done, I want to basically see what the results are. So we're executing this data model. I'm waiting for it to finish. And as you can see, my pipeline win prediction model has run, data flow has run. If I go over here into machine learning now, I can see there it is. It just ran pipeline win prediction. And what I want to do at this point is I want to find out, how well did it do? Now we're back to kind of doing this inspect step, where we can kind of validate or evaluate, how well this model actually worked. The general tab, as I said before, basically tells me what I did. If I look on the quality tab, I can see that I've got a very good coefficient of determination, which in other words means how well this thing predicts the result accurately. And I'm seeing a score of 86%, which, is a very good result. There are, as I said, some additional related pieces of information. Pipeline win prediction drivers is a good one, and really what this does is it allows you to see some additional correlations in your data, in your model, that kind of show you what really drives your predicted answer. So I'm trying to find out win probability here. And I can see that these in this first column are kind of showing me the higher the number here, positive or negative. So the negative ones have a negative impact. The positive ones have a positive impact. So right away, I can see some of the drivers that are important. And I also can see some of the drivers that I might want to redo this model and take out, to make it even better and to get rid of some of the noise. But the bottom line here is my model worked very well. I'm satisfied with the results. And now I want to apply it. I've just got a brand new set of data that came in from my vice president that I work for on the pipeline. And instead of going with the, subjective from the salesperson prediction, I now want to take a look at, how the model would predict the outcomes. So here I want to take a look at, I've created another one, and for the interest of time, we're not going to go through it. I've applied the win probability model to a data flow. Here I've now got my pipeline sales VP data set. Here I'm going to apply the model, and then I'm going to save it in a new data set called pipeline win prediction when I execute that data flow. So now, instead of taking that manually subjective entered win probability information, I now can use this model to more quantitatively define what those answers are. And we execute that data set, and when we get the results, we're now able to take a look at pipeline win prediction data set and see, what the predicted values are. As you can see, the very first column here is my predicted value. Now I can compare these predicted values to what the salesperson put in, and I also can create some visualizations and some graphs. But the key element here is that now I am able to take a look at these predicted values and use those, and I can provide that with my sales VP and basically say, here's what the model predicts. And I think that tends to answer questions that get you a little bit closer to coming home and answering the right questions with your information. So we're going to shut this down for now. And we're going to go back to our presentation. How am I doing for time? Okay. So let's take a quick look here at this data science out of the box. What do you get with this thing? The data visualization tool, and you're going to see the data science that's included with this tool. There are three model types. Numeric prediction is where you're going to predict measures. So like we just did, we wanted to predict a number, a probability. Binary classification is where you're going to predict values that only have two outcomes. So that's back to our admissions example where we wanted to predict yes or no, is this person going to enroll? And then the third type, is the more complicated one. It's a multiple classification where you want to predict multiple outcomes. These are your three model types, and within these model types, you can see you've got a choice of the different types of scripts. And as I said earlier, it's good practice to go through multiple scripts and see which one comes out with the best outcome. Each model, has these several scripts, and, you don't have to actually get into the algorithms, and I know what you're thinking, how do I know which model to choose? If you want to, you can do a little bit of research and find out, what each one of these things does. Or you basically say that I don't think you have to do that. It's a good thing. You can, remembering our 9th grade science lab experiment, we want to experiment here. Let's try 3 different models and pick the one that gives us the best result. So, the goal is to select a model script that best predicts the outcomes, and models that predict outcomes at a higher probability are the better models. Try a few of them, evaluate the results. And this is just another way of looking at this picture. I'm not going to get into this in detail, but it kind of shows you that not only do you've got model types and model scripts, but you also get results and statistics that you can use to kind of compare the results of your model. The functionality of all of these data sets kind of remains the same. Columns in a statistics data set changes between, for example, linear regression and logistic regression. But really, these data sets are all about you being able to evaluate how well your model actually did. I'm just going to focus in on a couple of the data sets here. The drivers data set is an important one. It's generated automatically by the model. It kind of shows, if you remember, some of the key determinants of your target column value. So, in our case, this model is performing a linear regression. It identifies columns in the data set that influence the target. It gives you what's known as a coefficient value, and the coefficients generated indicate which drivers basically are the strongest. This is important in understanding, your model and your data so that you can, going forward, understand that certain products, for example, have an influence on whether somebody's going to go ahead and have a high win probability. So this correlation kind of indicates the direction in general that you want to go with the relationship with the target column. There's another one here, called the confusion data set, matrix data set. Once again, we can see that our model only predicted incorrectly twice. I've highlighted that down here, and that's important because there's only one false positive, and this indicates that we have a good model when we evaluated the target values and what the model actually did. So once again, this doesn't kind of leave you in the dark as far as what these models do. It shows you right here statistically in ways that you can understand how well the model actually, what's the quality of the model, can I depend on it? And then finally, in our statistics data set, we can see that our accuracy is almost 96%. So an F1 score is also a measure of, test accuracy, and both of these are used to kind of determine, precision, how well, once again, the model works. And I think all of this is important for you when you start using this so that you can, with some confidence, know that your model is accurately forecasting those values. And, in our example, let's stop using these inputs that are subjective. Let's start using a model to basically predict what these probabilities of win are going to be. And more importantly, let's kind of start using the information as far as the drivers to focus in on the types of opportunities that we want to go for, because those are the ones that have the highest win probability. All right. I probably, scared you away at this point. Do we have too much data science so far? And if that's the case, if you don't feel like a data scientist now, this is just the tip of the iceberg. The good news really is that there's an explain function for those of you that don't want to go down the path that we've already been on. You're still going to have to do some learning on your own to understand models and algorithms, but more importantly, the explain function will get you there, easily. It's an inline machine learning for business users that doesn't have any specialty skills. It uncovers hidden drivers and can recommend areas of exploration without going through the process that we went through. And really, what you're able with the click of a button, you can, as you can see on the screen, explain a variable in your data set. So explain really, kind of guides you to key insights. And by that, I mean, similar to the data sets generated by the model scripts, explain also generates some data sets. So once again, you're able to evaluate, how well this explain is accurate. So let's walk through, one of these with using, let's say, our admissions data set. So I'm going to run to another demo here. This one will be a lot faster than the earlier one. So what I want to do here is I want to take a look at my admissions project. So I have an admit to enrollment project, and this is what my admissions analyst would be looking at. And what I want to understand, if we take a look at this, is this enrollment piece. Now, an important thing to understand when you're using explain is that explain can only be used on attributes and not measures. So there are ways around that when you have a number that you want to explain. But today we're just going to kind of scroll down here to enrollment. We right click on it and we go down here and we say, I want you to explain enrollment. So now it basically is going through my data set, it's crunching numbers, it's running some algorithms in the background to come out with what we call basic facts about enrollment. What are those basic facts? And it provides you, this is a data visualization tool, visually some interesting information. It tells us enrollment is a text attribute. It's got 2 unique values. It's either yes or no. It's been no 82% of the time. It shows you, if we scroll down, the values of enrollment by the measures in the data set, applicant count, admit count, high school grade point average. The nice thing about this feature is that any one of these visualizations that you see here, by clicking this button, I can add it to my project. So that now not only do I have the basics that I created in previously, I can now add some of these additional statistics to my project going forward. I can also look at this one. Once again, we're back to key drivers of enrollment. And as you can see, the 10 attributes most strongly correlated to the outcomes of enrollment are, it's something to do with name. And this is where, you could take some of these out. Academic plan, academic program, home state, academic career, whether they were admitted or accepted. And once again, it provides you visually, how these drivers impact enrollment, whether they go with yes or no. It also provides you an explanation of what's known as segments. I'm not getting that number here, and anomalies. So anomalies are where the model predicted one thing, and when it compared it to the data, there was a difference. And it basically says, this is an anomaly. It should have been this. It came up that. So the visuals, all of these visuals can be added to my project. If I just click on this button, and I click add selected, it basically will add it to the canvas, and it calls it explain enrollment. And there's my visualization. I don't particularly like those colors. So that's our second demo. I hope you kind of I've gotten a little bit familiar with, and you can see how easy this is. It's not really a heavy hitter type of a product. As far as, required, training and capabilities. And what it does is, I think it really excited me because I'm in here building models all the time now. It provides a lot of capabilities. So, in summary, machine learning and adaptive intelligence really with this tool is at your fingertips. There's a variety of data profiling. I mean, you're not going to become a data scientist by just using this tool, but you're going to be able to leverage a lot of the capabilities and understandings of a data scientist. I think that is a big step forward in opening the door to everyone to be able to apply data science in their everyday jobs. And I'm just going to basically close this out by saying, remember, you can't test out any of these features yourself unless you get your hands on it. So really, to learn more about this and these other machine learning features, go to Oracle and download the Oracle Data Visualization Desktop. It's easy to use. There are a lot of YouTube videos out there. Go for it. Try it. With that, I'm going to turn this back to Jason.
Thanks, John. Well, that brings us to the end of our webinar today. We appreciate everyone joining. We'll go ahead and open up the session for questions and comments today. I do want to point out and remind everyone again, our 5th and final webinar session will be next Thursday. And in our final session, we're going to dig into OBIEE, and for any users or clients out there that use the Oracle Business Intelligence Enterprise Edition for reporting dashboards and analytics, we're going to talk through the options and considerations of moving those into the Oracle Analytics BI cloud service. So looking forward to our final session next Thursday. And at this point, we will go ahead and open it up to any questions.
Thank you, Jason and Sean. If you haven't already, we now invite you to submit your questions in the webinar control panel. And our first question is, would you consider what we're going over to be BI or DV?
That's a great question. I would say both. From what I have seen in the market and the way that things are trending, to use a term that's run around a lot today, I see data visualization and business intelligence converging. They're kind of becoming one and the same. I'm using data visualization to do business intelligence. And within business intelligence, I have data visualization. I think Oracle's kind of seeing it that way as well. I'm seeing all of Oracle's focus in the data visualization capabilities. So I really see that as becoming the primary analytic tool.
Next question. It was my understanding that OAC BI includes data visualization. Did I hear you correctly when you said OAC BI and data visualization were 2 separate subscriptions?
That's actually true. So on the Oracle's Analytic Cloud, you basically get 3, it's a platform, and you get 3 products. You get the Essbase cloud service, which we covered in our previous 3 webinars. You get the data visualization cloud service, and you also get the BI cloud service. And it also now includes a data lake cloud service, which allows you to connect to an existing data lake. So really, this OAC is a complete analytic platform that provides you capabilities that you would have to buy 3, 4 separate tools to do. It all comes in one.
Yeah, and I would just add, Sean, to that, for those of you that might be interested in starting off with a smaller deployment or with one of those specific components, you do have the ability to look at a monthly subscription of, let's say, Essbase and data visualization only without BI, or a subscription of BI and data visualization only without Essbase. So there are some I guess, deployment options. And of course, as mentioned on some of our previous webinars, we can kind of help you analyze what your options are, but you can deploy this different ways depending on, if you want Essbase or if you don't want Essbase. And then of course, if you want to, use all three of the components versus potentially, one of the three or two of the three. But good question. Next question.
Next question. You made it look pretty simple. Is it really? What am I not getting?
Well, I'd like to answer that by basically saying, if I can do it, you can do it. All of these models that I built today in front of you, I basically, was able to build without doing any courses, homework, reading books. Basically, it goes back to what I think all of us already have learned, and that has to do with science. We work with data, and now we have a tool where we can apply it. So I think it definitely is as simple as I showed you in this webinar today. There are endless resources out there if you want to dive in deeper. I subscribe to 2, 3, 4 different blogs on machine learning, so I'm always kind of reading up on it. And I'm reading up on it without having to be a PhD.
Next question.
Yeah, and I would just add too, Sean, that part of our BI practice here at Sierra-Cedar, we do have the ability to do demonstrations and prototypes potentially, or proof of concept. So if it's something where you wanted to explore a certain data set or learn more about the features of data visualization or BI, we could certainly set up an hour with you to kind of go through, some additional demo examples as well. But next question.
How can I find out more about the models and the math?
If you reach out to me through my email address, I will send you some links to at least some of the blogs that I use that I have found are effective. I mean, obviously you can Google it, but you'll get a zillion responses. I found 3 or 4 that actually worked very well for me. Or I would say, engage me and let me see if I can put together a proof of concept with your data working with you.
Okay, next question. What if I want to write my own models?
That's a great question. So one of the nice things about this tool is if you've got some existing data scientists in your group, and they typically would be using the R language to write models and do programming. Basically, anything that they do in R can be incorporated into the data visualization tool. So if you've got your own models that you've already built, you can load those R models directly into the data visualization tool and use them.
Okay, thank you, Sean and Jason. I believe we've covered all of our questions. Is there anything else you'd like to add before we wrap up today?
I think this is a very exciting tool. I think we are on the verge of kind of a new era in the world of analytics. I would encourage all of you to reach out to us and let us see if we can work with you in a data set that you have to kind of show you, with your data, how this can help you. We do proof of concepts for free, and I'm happy to work with you. So,
all right. Well, thank you, everyone, for joining today, and we look forward to talking again next Thursday on our final webinar series. Thanks again, and have a good afternoon.
Thank you both. Great.
Yeah.
We hope to meet with you again next Thursday for our 5th and last webinar in this series, Assess and Migrate On-Premise OBIEE to Oracle Analytics Cloud Service. Thank you, everyone, for joining us. Have a wonderful rest of your day.
thank you.